Air maldistribution is an often found to be problem on furnaces with multiple burners. On furnaces with forced draft burners, often only the total flow to all burners is measured. On furnaces with natural draft burners, there is no airflow measurement at all. How are the different approaches to non-uniform air distribution on fired heaters with forced draft burners? In former days, the only measure was using experienced field operators and observation of the flame shape together with some indication on the excess oxygen in the flue gas. Not a very sophisticated approach. Since the 2000 years, computer fluid dynamics modeling, or CFD, became a tool to improve heater and air duct designs already during the detail engineering phase. Since approximately 10 years, there is an optimizing tool commercially available that measures air distribution in real time and allows for adjustment of air distribution on the running heater. Its name is Even and stands for even or uniform air distribution respectively. Here are the plus and minuses of both concepts. CFD can be, if properly used, a useful tool during detail engineering phase to design the combustion air fan, air duct, and/or air dampers. As in any CFD study, it is crucial that the boundary conditions and system requirements are selected correctly. For example, it is nonsense to model flame shape, heat flux, or whatsoever assuming uniform air distribution to all burners, while this might not be proofed. Even is not designed during a pre-operating phase of a furnace. The results of a CFD analysis are usually presented in the form of beautiful, colorful images, which usually seem to be great scientific proof for the client that the design was carried out correctly. The problem is that these only apply to the calculated operating cases at best and not necessarily to every real case. In addition, the accuracy can only be verified with detailed specialist knowledge of CFD modeling. As a rule, this does not apply to normal plant engineers and certainly not to plant operators. Even, on the other hand, is a measuring system that can measure the air distribution in real time and make it visible to the field operators and/or plant operators in the control room and make suggestions on how to counteract a potential uneven distribution. It therefore allows direct intervention in ongoing operations with virtually no time delay, which would not be possible with CFD without renewed efforts from PC-supported computer programs. CFD will always be a theoretically based analysis method without being able to check for design errors or inaccuracies. Even, on the other hand, physically measures the airflow rates indirectly via the airside pressure drops and therefore leaves no doubt about the quality of the air distribution. As has already been shown in many temporary and permanently installed Even systems, Even furnaces CFD modeled during detail engineering can have uneven distributions of up to plus/minus 20% and more in airflow. Furthermore, Even can easily verify burner designs regarding airside pressure drop, as both aspects can be crucial if problems with emissions compliance arise. If you think Even costs a lot more than CFD modeling, you're wrong. A simple version of Even costs about the same as CFD modeling, and you can use it at any time for the life of the furnace. Even is also easy to retrofit to existing furnaces and can help you to make safety-related aspects, such as setting the fuel-air ratio on each burner, possible in the first place. The safety standards for such systems, such as DIN EN 746-2 or the successor version DIN ISO EN 13577-2, stipulate such requirements, and in very rare cases are these met in process furnaces and oil refineries. If we have aroused your interest, please contact us. Our contact details are shown on the slide.
Emission Engineering. We engineer your emissions.